Hi guys, welcome to this video. This is chapter 7, functions, and today we're discussing functions, which are a very important part of Python because they really help us while writing algorithms due to several points which we'll just cover in a bit. So start it.
Yeah. And not just Python, if you're doing any programming language, as a matter of fact, functions are very useful. So now I'm presenting a code in front of you. This is a code of a very basic calculator. Okay, so now I want you guys to just look at this code, and now I'm just going to quickly run it to show you guys what I mean by this. So if I say 1 and I enter my two numbers as 2 and 3, it will print 5, right? Okay, so yeah. Anyway, now what we're gonna do is I'm gonna tell you guys that now see, whenever I want to say take two numbers from the user, I have to keep rerunning the program, right? Suppose I want to make 10 people use this calculator one by one. So obviously I can't actually go ahead and keep writing this code again and again. Obviously I can put in a for loop, but that will get really hectic. So now functions in fact will provide us a very easy method to go about this. Okay. So now how I'm going to do this is just watch how I write the syntax. Def means I'm defining a function. Calculate, I'm just going to call it CLC, and I'm going to call the this as command. This is now what this all is. We're going to explain very shortly. So just stay where you are now. I'm just going to copy paste this. In fact, I'll just call it X only. And I just copy paste this portion. Okay. Anyway, so now as you guys can see, what I have done over here is I have created a sort of function. No, I'm gonna put that. That's the part. Okay. Yeah. Okay, so I have created a sort of function over here with 3 variables x, a, and b. Now what these are, we're just going to explain shortly, but now I want you to see how I am changing this code. So now we have done these 3 things, and I will just say calc x, a, b. Okay. So now we have taken x, we have taken a, and we have taken b from the program's input. Anyway, so we have taken the 3 inputs from the program, and now what I'm doing is x, a, and b will fill these 3 places. And the second these 3 places are filled, it will go up here and it will perform the operations accordingly. And you guys can see it will do the exact same thing. So if I do this, and if I enter say 3, I enter 5 and 8, it prints 40. So now what happened is that these 3 variables x, a, and b were taken in these 3 positions. And the second I wrote calc. Now calc here is a function that I have defined for myself. Okay. So now calc takes these 3 values up here and it performs the operations accordingly, the same way you would expect them to. So what calc is, it is a function that I have defined for myself, for my needs. So now I can actually use this for 10 different users if I wish, by just putting a for loop about this, right? Anyway. So now let's come to what actually functions are. Now don't worry if you got a little confused in this, we're going to explain everything I just did here, and by the end of it you will be able to understand. So just keep up. So yeah.
Yeah, so functions are basically, it's a group of instructions or statements which can, when you use a function, it can perform a specific task. So what you do with a function is you first define it, and then you can call it later, which basically means you use it. When you call it, you use it. As Arjun defined the function in the beginning, then he called it afterwards. So why should we use functions? The first reason is it increases readability, especially for longer code, because once we have a function, we can reuse that code over and over again. And it's better to organize into different functions, because if we have one function, like one task is there, one task is here, we can put them in separate functions and use them later. The second thing is it reduces the code length. So we know if we define a function once, we can use it as many times as we like by just calling it. So just reduces the length a lot. And then that brings us to the next point, which is increases usability. And after that, it can easily be divided among team members and completed in parallel. So that means is many people can work at the same time because they can create different functions, which just makes it easier to work on a project together. Okay, so now we're going to start with creating a function, which is user-defined functions.
Right. So what I did up here was actually just creating user-defined functions. So now we're going to discuss what I actually do. So now the first command you write is def, which is actually short for define. So you write def and you write the function name. So suppose now I'm creating a very easy one, add, and I create a variable AB. Okay. And here I say print A plus B. This is a very easy function I just stated, and equals, suppose I'm going to give them its values for now. Okay, so I'm just going to comment everything. Okay. So now I have just created a function for myself. Now this is a user-defined function because I'm the user of this programming language, and I created a function called add, which when it takes two inputs and not exactly inputs, when it takes two values, okay, it just print the sum of their values. This is what my add function actually does. So as you guys can see, it prints 8, right? 2 to 6. So now what happened here is that I defined a function and I gave it two values by myself. And what I've done here is I've called the function. By calling it, I mean I have just done something to it which makes it do what this command says. Now inside here, there's actually just one very simple command, print A plus B. I can change the same thing into 3 lines of code, or 2 lines of code actually. So, same thing. But now this block of code, I've given a very easy example right now. So this block of code is going to be executed everywhere I do this, right? So now what are these values that you're passing here, and what are these A and B? Now let's talk about that.
Yeah, so we just learned how to define a function. So before we move on to the arguments and parameters, we have to talk about the key points of the syntax. So the first thing is, after you define the function and the function name and these things, you have to add a colon, and then it'll take you to first indentation level. So like, with every other thing, loops, conditionals, everything that's inside the function will have to be inside the indent. So you see this line next to the sums. So that's the first indentation level, right? So everything has to be in that, and then A is equal to and B is equal to 6 is not part of that. So it's outside that function. And after that, we'd also note that when you name a function, you name it like you would name a variable. So basically the identifier variable, yeah, the same rules apply. So you can't start with numbers and all that stuff that we discussed in chapter 5, I think. So that's the syntax basically. Now let's talk about arguments and parameters. So if you see here in def add up here, you have def add, then rounded brackets, then you have A comma B. So A comma B are known as parameters, and when we call add, it is 2 and 6. 2 and 6 are the arguments, right? So parameters are basically variables of the functions, while arguments are actual values. So the best way to remember them are arguments are actual values, and the parameters are the variables that we use inside the round brackets. So in a function, what happens is these variables A and B act like placeholders. So whatever values we input, like 2 becomes A and B becomes 6. So then sums will become 2 plus 6, right? Because these are placeholders for 2 and 6. And then we print sums. So that's what the function does.
Now we're going to talk about default parameters. Okay. So now we have actually shown you functions which take in parameters, but at the same time, we can actually just define a function, say hello, which doesn't in fact have parameters. It just has these round brackets. Okay. Okay. Now this function hello doesn't have any parameters, it doesn't have any weight, nothing. I just run it and I just call it the way it is. Like I just say hello. Okay. So when I run this, we get it just runs that very one line of code inside the command. So if I just run it, we can see it just prints hello the way it is because it has actually just one line of code, no parameters, no anything. But suppose I have a parameter and suppose I have two parameters A and B and I say hello A and B. But if I just say hello and I just put one parameter, I don't put the other one at all, what's gonna happen is it's going to return an error because it'll say it requires one more positional argument B, and B is the arbitrary variable that I have created, right? So now what happens in this case is like whenever you're creating a program for anyone or any random user, you don't know how your user will actually use the program and whether or not they will fulfill all the IDs or all the arguments that you need them to for the function to function. So now there's a way to go about that is to create default parameters. Now default parameters mean that default parameters are basically a way to give a default value to a variable inside a function. Like I have A equals to this AB, right? So instead of this, if I want A's default value to be Arjun and B's default value to be Samar, for example, right? This is how I write it. I just write A equals to Arjun, B equals to Samar. Now, what? If I don't put any parameters, so if I just write A, right? Now understand what's happening here. I'm going to print hello A and Samar. Now B, I did not give it, but it didn't return an error this time because I gave B the default value. So it printed B, the string inside B, and it printed A, and A I just called the string A, right? So it just went there and took that. But if I just call hello the way it is, without any parameters, it just print the full sentence. And if I give two different parameters, x, y, it will in fact replace both those parameters because now both the parameters that I have taken are filled with arguments, so they can't actually use the default values. Default values are only when the value isn't given by the user. So that's about how.
So default parameters are basically there as a way to give the function a value in case the user does not give it. So also one thing you have to notice that default parameters have to always come at the end in of the parameters, right? So if let's say I have 3 parameters, so I have A, B, C. So I have to make sure that the default parameters in this have to come at the end. So I can't have it like this, B is equal to 3, right? I cannot have that. Then the interpreter won't be able to interpret this code properly, right? See right here it says non-default argument follows default argument. So basically, once you define a default argument, everything else has to have a default argument. So I have to make this also for this to actually run properly.
You can't just have the first value as default and the rest of it is non-default. The last value, starting from behind, you can have as many default values. Okay. So that's about default values. Now let's talk about return. Right? Okay. So now the return is slightly different from what we've been doing. It's similar but a little different. Now I'll explain how. In this same program, they just say def hello name, and this time I'm calling my variable name print hello name. Okay, so now what this function will do is if I say hello x y z, suppose it will just print hello x y z, right? But now suppose I don't want to use the print command here. Instead, I will do something else. Now all of you watch. I do return hello name. And here instead of just okay, now if I do this, you guys will see what happens. I'm just calling the function the way it is. It does not return anything. That hello is in my previous program. This does not return anything. And And the reason for that is because I haven't printed anything. It just returned the value. So now what this means is that every time I call the function, this value is given to the function itself. Okay? So this I have when I call the function. Now after this program runs, the value that's after return is given to the function itself. So I can't just leave it this way. I need to print the whole function because the value is given to the function once I return. And if I do that, once I do that, you can see what happens. It just prints hello x y z. Now this is actually printing in a tuple. That's how return value is actually given. It'll actually probably make more sense if I do it in like with numbers. So you can see it just values given to the function.
Yes, now we have to talk about the default case. Basically, when there's no given output value, what will the function return? So let me define a quick function. Def add nums a b, then go add plus b. Then if I say return, let's say return without specifying what I want to return, and then if I call it, we get a none. So the default case is the function returns a none.
Yeah. So the reason for that is because now we haven't. Now as I told you, return gives a value to the function itself. But if I just give it a blank, so obviously that's gonna not give it any value. Instead, it's gonna return none. So that's what it does.
Yeah.
Alright, now let's talk about flow of execution in functions. Right? So I'm just going to take the same code and take it down. Okay, so we have this code here. Okay. So this code right here, I have a function hello with 2 parameters, and I'm not remembering that. So I have a function add with 2 parameters, and I have given it to So now, if you can notice, what happens here is now I want you to focus on the flow of execution. Okay. So what happened actually first? If I make it a little bigger and I say x equals 1. Now I have a few lines of code here. So if I do this, it'll ask me for num1. I'll say 4, num2 is 36, and it runs. Great. So what happened here? I wanted to focus on what actually ran first. So because this is at the top of the code, and if you're working on Python, you should know that it runs from top to bottom, right? But here, I noticed that these 2 lines came first. After it took the inputs, it went up here. Then it printed. So what is actually happening? This is what flow of execution means. So flow of execution is talking about the fact that when we have a function of here, okay, this block of code will only run when I call it, and it's up here for definition. So if I try to, it won't run the second the program starts. It will run only when it's called. So if I talk about the way it will execute, first it will execute input, then it will that, then it will execute the print command. Now the print command has a function inside it. Then it will go all the way to the top where the function is defined. So that's what it's like. Okay, now I am from here. What am I supposed to do? Okay, this definition is telling me I need to do this. Okay, I'll do it. And then it will just give us the output.
Yeah. Basically, the interpreter, what it does is it first ignores the function definition above. And then once the function is called, it goes back to those lines. Now let's try something else. Let me just take this code and run this here. So we input num1, num2. Now we got an error, right? Add is not defined. That means somehow the interpreter is not able to access this function here. So basically what happens is you have to define the function before you call it. So the function has to always be above the line you call it, because the interpreter has to go back to that function before you actually call it. You can't go afterwards.
Because interpreter, as we talked about this before, interpreter checks the code line by line. If we check the code line by line, it can't go down and check. Yeah. Okay. So scope of variable.
Yeah. So scope of the variable is basically where the variable can be accessed, right? So let me just explain with a simple example. So the different types of variables we have are local and global variable. So for example, let's say for a local variable, we can use the example of a country and the entire world, right? So let's say there's a food which is part of one country. So that food is local food of that country, right? But if there's a food which is consumed all across the world, it's a global food, right? So similarly, local variables are variables which can only be used in the particular function they're assigned values in, and global variables can basically be used anywhere in the entire program. So let me just show you how we can use that. So first let's look with local variable. Say def my func, and then let me give it two value parameters a and b. So if I say print a plus b, then I call it my a. So give it 2 and give it 3. Let me run this. Go first. So we have 5, right? So that's the local variable here are a and b. Basically, the parameters are the local variables because these variables cannot be used anywhere else. So let me say I want to print a. A is not defined, right? Because a is used in here. So that even if let's say I say x is equal to 5, then I say print x, then I can't find it because x is local to my func, right? So x can only be used here, it can't be used anywhere else in the program. Let me say I write global x, and if I run this, now suddenly I can print x afterwards, right? Because once you write global, it means that the entire program can access the variable. But when you don't mention global, only that function can access that variable.
So if you create a function, if you create a variable in a function, you actually want to use it somewhere outside the program, you just have to write the keyword global before writing the name of the function, writing the name of the variable, and give it a value, right? And this is a mistake that many people usually do make at the beginning. This is you cannot do this. You have to define. You have to first write global x, and in the next line you have to give it a keyword, which in this case is.
Looked at local and global variables. Let's talk about the Python standard library. So you might have noticed that while you've been programming, you've been using print, input. You might even used len. All of these are actually part of the Python standard library, and these are all functions. So you've been using functions all throughout your Python learning journey. So Python standard library is basically a library which comes installed with Python. So when you install the Python software from wherever you've installed it, this library comes built in. So it has built-in functions as well as built-in modules. So let's start with built-in functions.
Right. Okay, so now here's a list of a few built-in functions that Python actually provides us with. So I'm just going to quickly run them the show. Okay, so what are built-in functions? Like I just said, they are present in the Python standard library. So whenever you install it, you can get it. So the first function you have is apps. Okay, so this stands for absolute value, and this will just, as you would expect in math, absolute value would just take out the negative, convert it to positive, and let the positive be. right? So absolute value is just nothing but it gives a positive of any number you give. Okay. Then the next function we have is divmod. Basically, it okay. So whenever divmod means that if I'm just gonna give you an example. If I have 8 comma 5. So 1 comma 3. Now what is this? Basically, it prints the quotient and remainder. Okay. So 8 divided by 5 is 1, 3 minus 5, right? So the remainder is 3 and the quotient is 1. So it will print these in a tuple, as you can see over here. Next we have is the max function. So the max function is actually applicable for this. So max 2, 3, 7, 0, minus 5. As an example. If I run this, it prints 7 because 7 is the maximum value of the voltage. And we can we don't just actually have to give it like that. We can just give it based on we can even give a string in this for a fact. I can just say max of hello, and it's gonna print the string which has maximum sky value. So O has a maximum sky value, so it prints that. Okay. And remember, these numbers need not be integers, they can be floats, they can be anything. Now, same as max, as you would expect, the opposite exists min. 6 minus 2.5 minus 2.7 0 and 8. So now we will print the lowest value, which is minus 2.6, and like I said, you can do float values, and this is the way you would expect. You can do the same thing with strings with the sky values. Okay. Wait, I did max. Right. Okay, so now the reason is printing the capital letters because we covered this. Capital letters have lower sky value than the lowercase letters. Okay. Now we have a power, POW. Okay, so power is just the way you would expect it to be. If I have 7, 3, it'll just print 7 to the power 3. You can actually just do that by using basic arithmetic operator, but power provides one additional argument, which is we just take the modulus of that number with the third argument. So if I just take 2, okay, it's just giving the modulus of the number. Now modulus, I'm not talking about mathematical modulus, I'm talking about the programming, which is the percentage one. It just gives the remainder. So 343 with divided by 2 you get 1. So it just prints 1, right? So this is the third argument you can actually provide with the power function. Now the sum function is basically you can give it a list and it will just add all the list values together. 2, 3, 9, 1. And as you can see, it just adds all the values together. Other than that, I can even give it a value at the beginning. It's an optional argument. So I'm pretty sure when the function was defined, it was given a default parameter, which I'm assuming is 1 or 0 actually. So what this parameter does is it just adds the value to it. So 3. Right, that value comes right at the end. So this one value of integer can be added to the sum of these 3. So we can even just give it values directly. So this is what this does. And len is actually a function we've done in strings before. like it's very straightforward. Just return the length of the string that we provided. So as you can see what it's. So and type is also another function which is written by Python. If I have like you guys can probably guess what this is. If I have type 2, it will tell me it's a Boolean value. If I have type 2.4, it will tell me it's a float. So like you guys can go over that. So this is what all these inbuilt functions are.
Yep. Now we'll talk about inbuilt modules. So inbuilt modules are different, like packages, a collection of functions for different purposes, which are part of the Python standard library. So the three ones that we're going to talk about are math, random, and statistics. So you can probably guess from the name what they are. Math is for mathematical functions, random is to generate random numbers, and statistics is for statistics functions like mean, median, mode. So let's start with math. So in math, the first thing we do when we use a module is we have to import it. So what does it mean? We have to, like, if the file for the math module is somewhere in my computer, I have to get that file into my program, right? So to do that, I have to write import math. So this will basically will take all the files that are in the math program and bring them into my program. So I write import math, and then I can start with math.floor. Math.floor. So math.floor 4.4, right? So let me just try this once. Where to print once? Let me just print that. Yep. So you can see here, floor function. It's 4 because the floor function basically goes to the nearest integer value, which is less than the float, right? So what did I do here? So you can see I did math.floor. So the way to use a function from a different module is you first import the module, then you write the module name dot floor. So this is the floor function which belongs to math. So that's what you do if you want to use a function from a different library. And also the other functions we have, so you can do print math.ceil 4.4. So meaning the same number. That's what happens. So here we got 5 because the ceiling function, it goes to the next integer which is greater than 4.4. So we have floor is 4.4, it goes down to 4, and then C makes 4.4 5. Now next we have fabs. Print math.fab. So fab basically works for floats numbers, right? So it can be an integer or a float. So let me say minus 4.5, and it will give me the output as 4.5, basically the absolute value. Then if I go print math.factorial and go 6 and run it, I get 720. 720 is 6 factorial, right? So that's what this, it makes it much simpler instead of having to write it through a loop. Then if I go print GCD, and in the GCD you have to give two numbers. So let's say I get 15. Yeah, maths or GCD 15 and 3. When I run this, I get 3 because 3 is the greatest common divisor of 15 and 3. Now after that we have print pow, math.pow. So pow is basically power. So the first argument will be the base, and the second argument will be the power you want to raise it to. So 3 to the power 5, and when I run that, I get 243.0. It's a float value, note that, because we can also raise to decimal powers, like 5.2, and I get this. So note that this will return a float value. Okay, after that we have radians. So let's say I want to use print radians of 180. Math or radians, sorry. Math.radians of 180. Then we get pi, because 180 degrees is pi radians. And now if I go print math dot degrees, let me use 2 radians, we get 114.59 degrees. After that we have square root. So what we do is print math dot square root. We can use any number, we can use floats also. Then we get the square root of 233. After that we have sine and cos. You can go, that's very easy. So we go print math dot sine, and remember when you use a sine function, it is always in radians, right? Because the SI unit is radians. So we can, let's say I input 2 radians, sine of 2 radians will give me 0.9092, right? And then we can also make this cos, like cos of 2 radians. That becomes this. So that's the math module.
Good. So, like someone said, we have to use radians over here. So, if you want to like take a known value, suppose I want to do 120 degrees, so I'll do 2 pi by 3, right? So I'll do math dot pi, and I'll do 2 times that, so 2 pi, and then whole over 3. So now that's going to print the cos of 120 degrees, which is 0.5. So it will print approximately, okay, went negative. So it will print negative 0.5. So negative 4.9999 exact. Apparently the exact value according to Python. So we know that to be negative 0.5. And since it's cos in the second quarter. Anyway, back to that. Okay. Now we're going to talk about the random module. Like the name suggests, you can just take random values from it and it will work. Okay. So what does it actually do? We suppose like the way we just did above here, I'm gonna do import random. Okay. So now random is another module. So first the very basic command we have is just the way it is. There's no argument in this, random to random. What this will do is just print a random value between 0 and 1. Okay, so any value between 0 and 9 will just print 0.8%. Next time I run it, it will print 0.62, whatever. So it will print any value between 0 and 1. That's what the random function does. Now suppose I don't want to print a value from 0 to 1. I just want to print like a value from 10 to 100. What will I do? I'll do random dot rand int 1 to 100. I run that and this time it will print a value from 1 to 100. This time it will print 94. I run this again, it will print 77. Like, you guys can see what's happening. It's fix up a random number from 1 to 100 using an algorithm that's defined in the program, and you just pick that up and print it first. And there's one more. Now, if you don't want to give if you don't give a first value, and if you want to, if like you can just make it 0. So random dot range, and I do like say 50. Now it can pick up a number between 0 to 50. Okay, that's what the rand range function does. Pick up 5 this time, next time pick up 11, yeah, 26, and so on. And the thing is, you can only use positive values in this, but in the rand range function, I can say take my function on negative 100 to 100. So there's about 50% chance that my number will be negative. So here. And so on, like, that's how it works. So this is the 3 basic functions that you would want to know if you're using random.
Yeah. So the next thing, you can also use rand range for 2 values, right? So if you have 20 and 50, when you run it, then it prints number between 20 and 50, but that's only if you want it. Now we're going to talk about the statistics module. That's very easy as part of the CBSE syllabus. You only have the mean, median, and mode. So what we're going to do is we're going to import statistics, right? So let me create my data set first. So if I have data is equal to 365,190, right? Now we're going to look at the different functions. We have mean, median, mode. So I'm going to start with mean. Print statistics dot mean. What will that be? Mean of data, right? I run this, I get the mean as 4. So basically it added all these numbers and divided by the total number of elements. So if I go print statistics dot median data, right? Then I go this 4.0. So median will be a float, right? Because there are 6 values in this data set, so it will take the average of the middle 2 values. That's why it returns a float. Now if I print statistics dot mode of data. Now here we don't actually have a mode, right? So it takes the first value, but let me just add second 6. Right on this, we get the mode as 6, right? Now one useful thing you can do is this, I don't know if this is part of the syllabus, but you can write import statistics. Let me just delete this part here. So you can write import statistics as stats, right? Stats. This just makes it easier because it's easier to write stats instead of statistics. What it does is basically, instead of writing statistics to call the function, just use stats. So you can write print stats dot median, then give a list 3, 4, 5, 6. Right? Run this. You see, you can get 5.0 as a median, right? So basically, what it does is it takes statistics, and instead of using statistics, we just use stats. I can make it as S, and then if I use this, it gets S dot median, and we should get the same output. Yep, this is it's a very cool trick you can use.
It's like giving your library a nickname that you would want to use throughout the program, like sort of something like that. Think of it that way. Okay. Anyway, now the last thing we have is the from statement. So now the thing is, usually libraries are very huge, and you don't want to import the whole thing at once because it can actually take a lot of data. So suppose I want to, let's say I'm creating a game where the person has to guess a number that I have given. Suppose the computer chooses a random number, and I want the user to guess it. Now, obviously, the random function is a random module is a huge module. It has plenty of functions. So if I call it all, it'll obviously take up a lot of data. So to avoid that, there's one very useful thing called from. So from random, import random. So random is the command that I have imported. So from the whole huge module of random, I have just imported this very one command. And if I say x equals random 1 to 100 and y equals to int equal guess, and if x equals 1, then okay, I've just made a very small program where the user has to guess the number that the computer has chosen between 1 and 100. So if I run this, you can see it will work the exact same way. Say I say 6. It wasn't the right number, obviously. And let me just print it by so I can see what I actually guessed was right or not. So, print x here, x will just okay. So as you can see, the number that the computer chose was 76 and I guessed 7. So obviously that wasn't correct, so it didn't go to that. There's a 1 in 100 chance that you're going to get the number correct, and that's a pretty low chance, but it's there. Anyway, so the point that I'm trying to make here is that you can just import one very specific function. Another example for this can be, say you want to, if you're going to higher level programming, you will at some point make graphs. So suppose you want to make a graph of sin x. Now instead of in fact importing the whole math library, which we saw is huge, we just did a few functions with it. There's like inverse trigonometric functions, there's lots of things. The main thing is if I want to just import sin, so I just say from math import sin. and x equals to sine say math dot pi times 2 pi math dot pi by 6, suppose say pi by 6 times. So that'll be sine 30 degrees, which is a half, and that should sorry, comma 5. We can import more than one thing at the same time. Okay.
I think you put a multiplication sign.
Okay. Let's see. 3.14. Oh, okay. Just get over this program.
Yep.
And let's just say print x. So what's gonna happen here is it'll just print the value of sine 50 degrees, which is, I told you that 0.5 can approximate to 2.49999. Anyways, that's the thing. So I didn't in fact import everything from math. I just imported sine and pi, and I used them wherever I wanted. So remember, when you're just importing the function separately, you don't have to write module dot function. Like I didn't have to write math dot sine like I used to. Like we did over here, math dot power, whatever. You don't have to do that when you're just importing specific function. There we can just write it the way it is. Yeah.
Yep. Anyway, so what we can do is, if you want to find, we can use the syntax help module. So let's say I want to find a different function available to me in math. Right on that. This is what everything I have here, right? So I have all of these functions in math. This, right? This is basically a documentation of what I can get from this. So that's not really relevant to what you need to do, but just a cool tip you can use.
Yeah, this help command is pretty useful.
So that's it for functions. We'll be uploading tutorials to the website. So we'll add the link in the description. Check out our other videos. It's part of the playlist we have for the CBSE Class 11 syllabus. And besides that, subscribe to our channel and also check out our Instagram page. We post a lot of stuff on Instagram, especially Python tutorials. So if you want a quick revision, you can go there and check out our material. The link will also be in the description. Thank you for watching and see you next time.
And if you guys have any questions, drop them in the comments. We'll hope to answer them in the next video. Thank you.